And here comes this next question, the one that's often referred to as Bayes' rule. And here's the situation. Somebody walks in and you give them this test. They pass the test. Now the question becomes, what's the chance that this person is unqualified for the job? They pass the test, but you know the test is not perfect. There's still a small chance that the person is unqualified. The question is, what is that chance? So if I were to write this question using function notation, it would look something like this. What's the chance of not do job given that pass? What's the chance of that happening? Well, the reason it's called Bayes' rule is because it seems to be backwards from the information that's provided. When I read the tree, I usually think of starting here at any of the nodes and moving forward. This seems to suggest that I'm starting from the end. I know that the person passed. The question is, what's the chance that they happen to come from this path here where the person wasn't qualified to do the job? Well, again, if I look at structure, the the one on the right here with accounts, it seems that it's pretty easy to tell what the answer is going to be. We know then that we're only talking about 6,800 people plus the 40 people. That's it, because only these people passed the test. The question is, what's the chance that that person resides from one of the 40 here? Well, if that's all this is, then the answer is the following. And here's the result. 40 of the people will be in this category out of the 6,800 plus the 40. And that's, you can see from the counts how easy it is to come up with that calculation. This is the whole, the pass is the whole, so there's the 6,800, here's the 40. That's what the bottom is always the whole, the sample space. The top is what you want to happen, and what you want to happen is not do job. And it turns out 40 people pass the test, but still not able to do the job. So how would this look like if I just used the tree on the left? Well, just look at how the numbers are generated. The 40, for example, is generated from the 20% times the 2%. So I'm just going to replace the numbers with their decimals, basically how they were derived. And here's what this looks like right here. So the 40 comes from 20% of the population is not able to do the job, and then 2% of those still pass the test. And then you look at the denominator, again, it's where the people who pass the test. So here is, for example, the ability to pass the test, which should sit in the denominator since this is the whole. So the passing the test is the whole, and notice in part B, we calculated the chance of the whole pass the test. So look at these as often as you like, and I'll try to do another problem similar to this so you can get another idea of how these problems work out. But again, this last problem here is called Bayes' rule.